Measuring AM Modulation Index. The goal of this video is to show you how to measure AM Modulation Index. In the AM envelope, that's V max and this is V min. Whiteboard please. Percentage modulation equals V max minus V min over V max plus V min times 100 over 1. Back to the video. Hi there, this is Tony and this is my demonstration on how to put an AM carrier up from a mini lab using a function generator and a cathode ray oscilloscope. This is 100 kilohertz shown on a cathode ray oscilloscope generated from a mini lab. Notice here we've got I'll zoom in a little bit on this. That's actually a carrier of 100 kilohertz, and to prove that we put our trace down here down to 1 microsecond per division, and then we adjust our triggering trace there and coming back over here to our mini lab, and we've got to have 100 times roughly about 1 or so, or thereabouts. Just bring it back to the oscilloscope here, and if we adjust here for 0, we adjust the trace for 0. There's a little bit of trace rotation there. Put that up to the AC there. In this part of the video we have a look at 100 kilohertz. There's 10 divisions there on the cathode ray oscilloscope. 10 divisions times 1 microseconds equals 10 microseconds. Frequency equals 1 over period. Frequency equals 1 over 10 microseconds, which frequency equals 100 kilohertz. From there I've moved my oscilloscope back up here to show the carrier again. So I'll do that step again. I'll bring that down to 1 microsecond, and we have pretty much there 100 kilohertz, which is 10 divisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll bring that here, put it on. 10 times 1 microsecond is 10 microseconds, and 1 over 10 microseconds is 100 kilohertz. So we knock this down here to display our carrier again down to 0.2 milliseconds, and then we move over here to our mini lab. It's got the AM modulation on here. I've got 1 kilohertz here, 1 times 1K from our Beckman industrial function generator. And then back to our mini lab, and then what we do is we turn this AM on and move back to the oscilloscope, like so. We can see our AM envelope running away there, and we adjust it down here, the trigger. We adjust the trigger down here, and there's our AM envelope there. To measure modulation index, there's V max minus V min, V max plus V min times 100 over 1, which should give us our percentage there. To work out our modulation percentage on this waveform, we can move the crow trace around like so. Okay, and measure our V min figure, which is up here, and have a look at 1.1 divisions times 5 volts We note that down. And then for our Vmax, we bring our row trace up here, bring that there like so, and measure that, and that's 1, 2, 3, 3.6 times 5 volts, and note that down there.
Blank board, clean whiteboard please, AM envelope, 1 kHz on AM envelope, 100 kHz carrier component, Vmin equals 1.1 divisions times 5 volts equals 5.5 volts, Vmax 3.6 divisions times 5 volts equals 18 volts. 12.5 volts divided by 23.5 volts equals 0.319 times 100, 53.2% AM Modulation Index.
And we can adjust the modulation level here, like so. And that's pretty much at 100%. Notice where it's touching around here and here. For overmodulation, we overdrive that and we start to distort the envelope with this one, and that's for overmodulation there. That's here. It's getting a little bit of clipping on the top, and here is overmodulation there.
Here we have the Minilab with a 100 kHz carrier. Here is our calculation on the whiteboard with 53.2 modulation index. Here is our calculated 53.2% modulation index on the cathode ray oscilloscope. Here is 100% modulation index on the cathode ray oscilloscope, and here is overmodulation on the cathode ray oscilloscope. With a capacitive coupled CRO probe, it is possible to see the AM waveform on a cathode ray oscilloscope. Various CBs can be used to check AM modulation, including a President Jackson AM single sideband 40 channel, a Grundig 40 channel AM set, a Colt 40 channel all mode CB set on channel 14, this one, and a multi-band 40 channel Allen multi-mode with 240 channels in a 6-band CB radio. These are just a few various different CB radios that can be used as an example.